energy levels. Have you ever heard about the energy level? Yeah, Aisha and Hafsa. Let me wait a 5 minutes for also Amna. Yeah, Aisha. Do you know about the energy level? Have you heard about the energy levels?
No.
Okay, Hafsa, what is energy level and what is the structure of atom? As you all know, the structure of atom is like that there is a nucleus in the center. If this is the atom is considered to be spherical. So the nucleus is at the center of atom. It's fine.
Yes.
And electron is revolving around atom. Electron, okay? Now, what would happen? Electron will not leave its orbit, okay? This electron will not leave its orbit, okay? Until unless energy is provided to electron. It's fine now. Yeah.
Yes, sir.
Okay. Now what would happen? Now listen carefully. What would happen that if the energy is provided, like for example, this is our second orbit. If we give the energy of photon to that electron, now what happened? Do you know energy of photon is HF? Now what would happen if you give the energy of photon to that electron? This electron jumps to the higher level. This electron jumps to the higher level. It's fine. Yeah, and this process is known as when it is electron jumps to the higher level. This process is known as excitation. Have you heard about excitation? Yeah. Yeah, Aisha.
No.
Okay. Okay, kindly write the excitation. What is excitation? Excitation. So excitation means when electron or atoms absorbed energy in form of photon, it jumps to higher level. And that level is basically called energy level, okay? This is the energy level. So it means they go to the higher energy level. It's fine? Yeah.
Yes.
But now the next sentence is very important, okay? But the electron will not will not placed at higher level forever. Forever means it will not be at high excited state forever. It electron will come back, comes back to its original energy level. It's fine. Within
Yes.
within 10 to power minus 8, 10 less to power minus 8 seconds. Okay. It will not spend more than 10 less to power minus 8 seconds. Now, what would happen if the electron, this electron, which is at the excited state, coming back to its original state, it will release the energy or release the energy in form of photon. Okay. Now, and this process is known as de-excitation. De-excitation. Now, the question arises, what is de-excitation? Okay, right. De-excitation that when electron or atom release the energy, release the energy to jump back, to jumps back to its initial state, initial or original energy level. So, and this energy release in form of photon. It's fine? Yeah.
Yeah.
Okay. Okay. Now the question arises, how much energy we will give to the electron so that can move from one energy level to another energy level. Okay, the question this arises. Have you noted that? Have you noted that? Yeah, yeah.
Yes, sir.
Okay, okay. Now that is very important question. Okay, now I am moving toward very important question. If you have any confusion, kindly ask. Okay, I am making the energy level now in the horizontal form. Okay, in the horizontal form. Yeah, it's fine.
Yes.
Okay. So if any confusion, kindly ask. Okay. So this is the first energy level. This is my second energy level. This is my third energy level. This is the fourth. And this is so on. Okay. Yeah. That's fine. These are the energy levels. Energy levels means the orbits. Okay. Energy level means the orbits. That's fine. Now, for example, this is the first energy level, means first orbit. Do you know orbit, Aisha? What is orbit? What
And
is
this is
orbit?
not a surrounding.
Exactly. The orbit is the place where the electron is revolving. Yeah, and Hafsa, where is the orbit? Where will be the orbit place?
It's around the nucleus.
Around the nucleus. That's good. That's good. So if I call this one is excited states now, excited state now. Now, this diagram will be given you in the paper, okay? You do not need to memorize that diagram. Only you need to see the method, okay? The energy of first level is minus 13.6 6 EV. What do you mean by EV? Yeah. What do you mean by EV? Yeah. EV. electron volt. What do you mean by EV? Electron volt. And 1 electron volt is equal to 1.6 into 10 raised to power minus 19 joule. It's fine. Last time I have written this value. Electron volt is also the unit of energy. Okay. In the
Yes.
atomic level. So in the atomic level. So what is the energy of first state? That is minus 13.6 eV. Why the minus sign is written here? The question arises why this minus sign is written here. Yeah, if you are not asking the question, then I will ask the question. Yeah, Hafsa, why the minus sign is there? Yeah, Hafsa.
Um, I'm not sure.
Okay, yeah, Aisha.
I don't know.
Because it is the potential energy, okay? So it is the potential energy, means that much energy absorbed by electron to free from atom, okay? And in atomic level, whenever we put a sign of negative, so it means that is a potential energy. It's fine. It's fine now.
Yes.
Yeah. Okay. So don't worry about the minus. They will not ask about the minus in the paper, but you must know that what do you mean by minus sign? Means that much energy you will give to that electron in this energy level. Okay. Now, what is the energy level of second orbit? That is 3.4 electron volt. What is the energy of third orbit? That is minus 1.51 electron volt. And what is the energy of fourth orbit? That is minus 0.85 electron volt. Okay. These energy levels values are experimental. Okay. So you do not need to memorize it. In the paper, they will give you. Okay. It's fine.
Yes, sir.
Now, one by one, I will ask the question, okay? I think Amna is not there today. So, yeah, first of all, Aisha. Aisha, my electron is here in the first state, okay? I want to move electron from the first state to second state. How much energy I will give to that electron? Yeah. Have you understand my question?
Yes, I understand.
So what will be your answer? That how much energy this electron will be absorbed, then it will go to the excited state of second level. Yeah,
10.2 minus 10.2.
that's good. That's good. So it means you have subtracted the energies of the two level. Okay. So it means if you give that 10.2 electron volt energy to this electron will go to the second orbit. It's fine. It's fine now.
Yes.
That's good. Okay, let's Aisha. Who give the answer? Hafsa, you give the answer. Yeah, Aisha.
No, that's Aisha.
Aisha. Okay, so Hafsa. Now I want to move this electron to the fourth state. Now, what I will do? Yeah. How much energy I will give to that electron so that electron can move easily to the fourth level. Yeah,
We will subtract them.
exactly. So we will subtract the minus 0.85 electron volt minus 13.6 electron volt. And what you will get the answer? Yeah, can you calculate it?
12.75.
How many?
12.75.
12.75 electron volt. So if I give the energy of 12.75 to that electron, this electron will goes to the fourth energy level. It's fine. Now, there is a question, who will answer that? Now, these two, both electrons are moving to the excited state, okay? Now, who will answer that question? That if I give the electron to 13.6 electron volt energy, what happened to that electron? Yeah, Aisha, what do you think? What happened to that electron if I give the energy of 13.6 electron volt to the electron? Yeah.
It will move from the first orbital to the second.
No, 13.6. For the second, you need 10.2. It will be ionized. Okay? It will be ionized. What do you mean by ionized? The electron will free from the atom. It's fine. Now it is not coming back. It is free from the atom. The atom get a positive sign. Have you studied in chemistry the ionization? Ions, ions. Have you know the ions?
Ye-
Yeah, what do
Yes,
you mean by ions? Can somebody explain me what is ions?
there are the charged particles.
They are the charged
Charged
particle and with positive and negative sign, as you know that, as you know. So how can somebody give me an example of any ion? Yeah,
sodium ion.
sodium ion. What is the sodium ion? Can you give me its plus or minus?
Plus.
Plus. So it means it have the more number of proton and less number of electron. It's fine. Now, the chlorine is the second ion with the negative sign. You know that. So it means the chlorine has more number of electron as compared to proton. Fine? Yeah. Yeah. Any question? Yeah. Have you understand this concept?
Yes,
Okay. So if the atom ionize the electron, so it give negative, it give positive number. But if the electron is absorbed by the atom, that atom get the negative sign. Okay, like sodium chloride has lose one electron, so that's why it get positive ion, and chlorine has gain one electron, so that's why it get negative ion. That's fine now? Yeah. Okay.
yes, yes.
Yeah. Okay. Now coming to the another part of the question on the same diagram, I will not making the diagram again. So on the same diagram, okay, I'm going to do that question. Okay. Now, yeah, Aisha, if I want to move the electron to the second orbit, what I will do? Yeah. Yeah, Aisha. What I will do? Yeah, Aisha. If I want to move that electron to the second orbit, what I will do?
We need to provide the electron energy with.
Photon energy. Photon energy. So we need to give the photon energy to that electron. Okay. And this energy will be approximately 10.2 electron volt. It's fine now. So this method is called absorption of energy. Absorption of energy. And now, have you understand that? Yeah, have you understand that,
Yes.
Aisha?
Yes.
Okay, now Hafsa, can you tell me that electron is already in the second orbit? Now the electron is now coming back to the first orbit. How much energy will be released by this electron? Yeah, how much energy will be released by this electron?
10.2.
Exactly. So again, it will be released the energy of photon, and that photon energy will be 10.2 electron volt. It means the difference of the two energy level will be equal to energy of photon. It's fine. So this is our equation. So difference of two energy level is equal to energy of photon. It's fine? Yeah. Any question? Yeah, Aisha and Hafsa? It's
No,
fine.
sir.
Okay. Now, coming back to another concept, do you know a spectrum? What do you mean by spectrum? Yeah. Do you know a spectrum? Yeah, Aisha?
Yes.
What is a spectrum?
When white light it refracts, seven colors are produced.
Exactly. So spectrum is the splitting of white light into seven colors or into colors. Okay, colors. It's called a spectrum. Now there are two types of a spectrum. Okay, one is called continuous spectrum. Continuous spectrum. Now, what is continuous spectrum? The spectrum which get from the heating or from gases, means in our daily life. Okay, from the heating or the gases. Okay, yeah, like as Aisha says, like as Aisha says that white light is converted into the by using prism. Do you know prism? What is prism? Yeah.
Yes.
So by using prism, we can convert the white light into the normal white light, which is coming from the sun as a heating. It can be split into the seven colors. So this is the continuous spectrum. The identification of continuous spectrum that we cannot in continuous spectrum we cannot differentiate between the boundaries of color. Okay, the boundaries of colors. Have you seen the spectrum which is made after the raining? Yeah, Hafsa, have you seen that spectrum?
Yes.
after the rain which is made on the sky. Can you differentiate between the colors? So you will not be able to differentiate between the
No, sir.
boundaries of the color. Yeah, sorry.
No, sir.
Yeah, yeah. So because there are blurriness in the spectrum, and that's why you cannot differentiate between the boundaries of that color. This is called continuous spectrum. Okay. The second type of spectrum is called line spectrum. It can be line or it can be discrete. Okay. Line or discrete spectrum. The spectrum we get from the excitation and de-excitation of the energy level, excitation and de-excitation of the electron in the atom. Okay, so it means line spectrum, or you can say discrete spectrum, is a basic type which is seen in the atom, okay, due to the excitation and de-excitation of electron. That's fine. Yeah.
Yes, sir.
Have you noted that? Yeah, Aisha and Hafsa.
Yes, sir.
Okay. Okay, now coming toward the types of line spectrum. Now line or discrete spectrum has two types. One is called emission line spectrum or discrete spectrum. Yeah. Okay. So what do you mean by emission? Yeah, Aisha. What do you mean by emission? Yeah, Aisha.
Pro-
Emission. Yeah, can
producing
you?
something?
So emission means releasing of energy. Which energy? Photon energy. Okay. Photon energy during de-excitation. During de-excitation of electron in atom. It's fine.
Yes.
Yeah. How, Aisha, how you know that? Can you see the electron? Hafsa, can you see the electron or atom?
No, sir.
Then how you can say that there is an electron, there is an atom? So we can identify the electron and the atom by these spectrum lines, okay? With the help of these spectrum lines, so we can identify the electron and the atom, okay? That's fine. Now, as I written that emission is the release of energy during de-excitation of electron. Now, what would happen? Yeah. So during de-excitation, the electron will release the energy, and that release of energy is observed in form of spectrum. It's fine. Yeah.
Yes.
remember that in the book, how you know that this is the emission spectrum. So remember that the background of the emission spectrum is black. I am going to repeat again. The background of the emission spectrum is black. It's fine, or it is dark color. It is dark, okay? Yeah. And there will be a lines. So that's why it is called line spectrum, because the lines are there. Colored lines will be there on this spectrum, on this band, okay? Yeah, Hafsa? Yeah.
Yes, sir.
What do you think? What this color give us? What do you think? What this color is giving us? Yeah. Yeah. Aisha, what do you think? What this color is showing us?
The light will emit.
Yeah, that's good. That's good. That these colors show that electron is de-excited from which level? From which level? Have you understand it? Like as Aisha, I asked from you that when the electron coming back to from the second shell, second level, second state, it will release 10.2 electron volt energy. Okay. And when I asked from the Hafsa that electron is coming from the fourth energy level to the first energy level, that will release the how much energy? That will be 12.75 electron volt energy. It's fine. So the color identified that from where the electron is coming back to which shell. It's fine. It's fine now. Yeah.
Yes, sir.
Yeah, Hafsa, have you understand it? Yeah.
Yes,
Yeah, Hafsa.
yes.
Can you repeat? So what I have, can you repeat it that what is the meaning of these colors? Yeah.
That the electron is
Yeah, Hafsa.
de-excited. That
Exactly from
electron
which
is
level?
de-excited.
Okay. So that is the,
Uh,
yeah, okay. And what the color tell us? Color tells us that electron is coming de-excited from which level? Okay. From which level? It's fine. Yeah.
Yes, sir.
Yeah, Hafsa.
Yes,
Okay.
sir.
Now, the second is the absorption line spectrum. Okay. The second one is the absorption line or discrete spectrum. Now, Aisha, can you tell me what I have told you that if I want to move the electron from first state to second state, what I will do? Yeah.
We need to provide the photon energy.
Exactly. And you told me that because there is a difference of energy level between the two states, first and the second state is 10.2 electron volt. So that's why if I give the 10.2 electron volt to the electron will absorb that energy and move from first shell to another shell. Okay. So absorption line spectrum basically the spectrum found or you can say observed during excitation Yeah, Hafza, what do you mean by excitation? Yeah, Hafza.
When the electron absorbs the energy
Exactly, and jumps to
at
the
the
higher level.
higher level.
Yeah, that's good. That's good. So that is called excitation. So how how will be the spectrum of excitation? So remember that the background,
It will be white.
not white, but it will be colored. You can say colored. Background will be, who says Aisha?
No,
Hafsa. Yeah, white can be possible, but its background will be light color. We can say light in colors. Light means if the blue background will be there, then that color should be lighter. Okay. So
okay.
the background will be, the white is also correct, but the mostly background is observed colored. Okay. Yeah. Can you ask why it is colored? Why it is colored, Hafsa? Or why you say white?
Because the energy it's absorbing.
Exactly. Energy is absorbing, and there will be a dark lines. Okay. There will be a dark lines during this absorption spectrum. Yeah, it's fine. Yeah, Aisha.
Yes.
Have
Yes.
you understand it, Aisha? Because Hafsa knows that the background will be the light color, but have you understand it that? Yeah, Aisha.
Yes.
Okay. Can you tell me, Aisha, why that dark lines will be there? Why not the color lines? Why the dark lines is there?
The lines are produced because of the absorption of light.
No, no, light is not produced. Light is taken out, means absorbed. It is absorbed by the electron. So that's why now for the color you need the white light, okay? So if the white light is not providing, then no color will be observed there. So that's why we observe the black lines, okay? That's why we observe the black lines. It's fine. Yeah.
Yes.
Okay. Yeah, Aisha and Hafsa. With this, we have complete our waves chapter. Now, is there any question in the quantum theory you can ask? Otherwise, I'm first going to summarize that energy levels and this all topics. Yeah, yeah. Any question?
I wanted to ask about the discrete one.
Yeah, yeah.
Is it when the
Yeah.
electron is coming down the energy levels?
Sorry, can you repeat again?
Is it when the electrons are moving down the energy levels?
You are asking about that. What is meant by discrete?
Yeah.
Okay, so discrete is a basically that have you seen that I have written two names? One is called discrete, another one is called line. So first of all, I will give the answer why it is called line. Because the spectrum is given in the line form. So that's why it is called line. Okay. Now, what do you mean by discreteness? Now, this is the very interesting question. Have you seen how I made the energy level?
Yes, sir.
This is my first energy level. This is my second. This is my third. This is my fourth. I made it energy level with count of 1, 2, 3, 4. It's fine. Is I given the
Yes.
energy level of 1.5 or means zero point 0.5 somewhere? Yeah. Have I given during that diagram? Yeah,
No.
last diagram. So it means the energy levels are the energy states are always in the integer forms. In the integer forms. Okay. Integer form means in whole number, means 1, 2, 3, 4, 5. It's fine. So that's why this is called discreteness. Okay. This called discreteness. Yeah.
Okay, sir.
Like your stairs. How many you are living in flats somewhere? I hope so. Yeah.
Yes,
Or you
sir.
are okay. How many stairs uh, is there to reach at your flat? कितनी stairs है बेटा? How many stairs are there? जी.
There are a lot of stairs.
For example, consider to be that 50 stairs are there. Okay, consider that okay, 50 stairs
Okay.
हैं. It's fine. Now, can you say if somebody asks from you how many stairs are there, you say it is in between 50 and 49. Means it can be possible 50.5 or it can be possible 49.5. Can it can it number can be possible? Yeah.
No.
50. Why? 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 Because the middle number of stairs cannot be possible. And this is called discreteness. This is called discreteness. Okay. The stairs are always in
Okay, sir.
discrete form. And similarly, when I made the lines here, the lines are always made in the boundary. Their boundaries are, you can differentiate the boundaries of lines. So that's why it is called discreteness. Yeah.
Okay, sir.
Have you, Aisha, Aisha, can you, have you understand that? Yeah, Aisha.
Yes.
Okay. So, Aisha, your voice is too low. Is there any question? Yeah, Aisha.
No, sir.
Hafza? Yeah.
No, sir.
Okay. So now we are going to summarize full lecture. Okay. Now we are going to summarize the whole lecture. Summary of the lectures. Kindly, if you know the summary of lecture, you can also be attempt the question. Okay. Now we started with the electromagnetic waves, means light. Okay. And we says light can travel through vacuum. Light in shape are transverse wave. And the speed of light is 3 into 10 raised to power 8 meter per second. That's fine. Then we says light is a dual nature. Yeah, Aisha, have you remember what do you mean by dual nature?
Yes.
What do you mean by dual nature?
Light can exist in two forms, in particle or waves form.
That's good. That's good. So dual means the light can be in wave nature and the light can be in particle nature. And this thing is given first time by a scientist whose name is de Broglie. And he also gave the equation which show the relationship between wave and the particle nature, that is lambda is equal to h by p. Or you can say lambda is equal to h by mv because p is equal to mv. Yeah. Can you, Aisha, tell me that what is h, what is lambda, what is p? Yeah.
Lambda is wavelength,
Yeah.
h is Planck's constant,
And
and
p?
p is momentum.
Yeah. Hafsa, can you tell me which physical quantity is a property of wave and which physical quantity is a property of particle? Yeah.
For waves, it's diffraction, refraction, reflection,
No,
interference, and
no,
polarization.
that's fine. That's fine. That's fine. You are talking about phenomena. My question is that in these three forms, in this equation, which physical quantity is a property of waves and which physical quantity is a property of
Wavelength.
wavelength is the property of waves
Okay.
and momentum
For particles.
exactly is the show the nature of particles. Now, as Hafsa says that for the wave nature, you must know the phenomena of refraction, diffraction, interference, and polarization. That is in our courses, okay? But for the particle nature, we have done the one experiment that is, yeah, that is,
Photoelectric effect.
that's good, photoelectric effect. So now, coming toward the photo effect. So photoelectric effect, photoelectric effect gives the particle nature of light, and the electron which is emitted by photoelectric effect is called photoelectrons. And photoelectrons depends on two things. One is called wavelength, or you can say frequency of photons. Okay. And the second thing is called metal nature. Yeah, can you tell me, Hafza, in which property it is independent? Photoelectronic emission is independent. Yeah, have you remember? Yeah, Hafza, that
Um,
photoelectron emission is independent of which physical quantity? That
on
is
energy of photon.
intensity of light, intensity of photon. Okay. So it doesn't depend on the intensity of photon. Yeah, Aisha, can you tell me that what is the energy of photon? Energy of photon formula. Yeah,
E is equals to HF.
that's good. E is equal to HF, or you can write E is equal to HC divided by lambda. So because F is equal to C by lambda, so that's why you can write E is equal to HC by lambda. Now, there is an equation, Einstein equation, Einstein equation for photoelectric effect that was, have you remember it? HF is equal to phi plus half mv square maxima. That's fine. What is phi?
Work friendship.
That's good. That's good. Yeah, the Hafza, you answer the
Yeah.
question. Okay, so can you answer, Aisha, what is threshold frequency?
Um, the
Minimum
minimum
frequency.
frequency required to eject an electron from the metal surface.
That's good. That's good. So this equation is very important whenever the questions come on the photoelectric effect. So this equation is required. Okay. Now, the last part which we have discussed today, that is the energy levels diagram or energy levels state, and for this you need the equation E2 minus E1 is equal to HF. So HF is the frequency, is the energy of photon is equal to the difference of the energy level. And we have the two type of a spectrum. That one is called emission spectrum. That will be the line emission spectrum. And the second one is called line absorption spectrum. Yeah. Any question? Yeah. Any question, please?
No, sir.
Hmm. If the question is not there, well, then I will ask the question. Okay. Yeah. Can I ask question?
Yes, sir.
Okay. So, Aisha, can you tell me that filament bulb give which kind of a spectrum? Filament bulb. Yeah. Yeah, Aisha.
Mm,
Filament bulb.
um,
Yeah. Hafza. Filament bulb gives which kind of a spectrum?
electromagnetic.
That a continuous spectrum. Okay.
Okay.
Continuous spectrum. If you remember, I have written that continuous spectrum gives the heating and the gases. So filament of bulb is given the spectrum due to the heating. Okay. So the filament of bulb gives the continuous spectrum. Okay. That is not the line or discrete spectrum. That is the continuous spectrum. Yeah. Yeah, Aisha, it's
Okay.
fine.
Yes.
How I know that this is the continuous spectrum? Can you give me some hint? How I know that this is the continuous spectrum? Yeah.
Because of heat energy.
Okay, okay. Yeah. Afza, what's your response on that question? How I know that it is the continuous spectrum?
We won't be able to differentiate
Between
the
the
colors.
boundaries of color. That's good. So when the spectrums taken from the bulb, we cannot differentiate between the boundaries of that color. So that's why it is called continuous spectrum. Now, as we completed the wave topic, so next time we will going to do the paper. Okay. Now, in next two lectures, we are going to do the papers now. Okay. It's fine. Yeah.
Okay.
So now we will see how the question is coming from the waves and is we are able to attempt the question or not. And my request is that when we are going to do the paper, at that time, you have to place your handouts in front of you. Okay? You place your handouts in front of you that you will be able to answer any kind of question. Okay.